I mean, we are record. Okay, so what was I saying? So, yeah, it's a rule of thumb. It doesn't work all the time, huh? This only works around 80% of the time. To how do you select u and v prime? The ultimate objective, the ultimate goal of integration by parts is to break it down into a simpler integral. When you take uv minus integral of u prime v, this integral of this u prime v has to be easy to integrate, or more like possible to integrate. Don't say easy. Easy is subjective. Easy is very subjective. You just need possible. Okay. So let's go. So yes, it's x and cosine. So let's differentiate x, we get 1. Let's integrate cosine, we get sine 5x divided by 5. I know you need a plus c, right? But never mind, we can drop it for now. Later, at the very last step, then we put a plus c because the constant is just arbitrary. We can just put a single constant. Then the formula tells you what? The formula tells you to take the left diagonal minus away the horizontal integral of the horizontal pair. So what does it mean? Take the left diagonal, which is u times v. So u is your bracket, v is sine 5x over 5. That bracket minus integral of, take the horizontal diagonal, u prime v. So it's 1 times sine 5x over 5. I hope you understand that multiplication left and right doesn't matter. Left times right, right times left. So you can swap the order around. Okay. But must remember it's uv, then minus integral u prime v. And the setup, the top left and the top right must be u and v prime. Okay. This is the systematic way to do it without thinking too hard. Okay. Yeah. Okay, then we continue simplifying. That's the end of integration by parts. We continue. Then this part becomes x sine 5x all divided by 5 minus away. Oh, by the way, I forgot. This is a definite integral, so I actually need a square bracket. I put down the limits 0, 0.5 pi. Same thing, 0.5 pi. And for this integral, you realize there's a 1 times, you can essentially ignore it. 1/5, you can factorize it out. So negative 1/5 integral of sine 5x dx. And if you are faster, you can realize that, oh, actually, this is just negative cosine 5x, right? So you can skip a step like this. Look at what I'm writing up. I bring it down. I just copy down the expression from before, but I change a little bit. I don't put equal sign because it's not equal. I'm only doing halfway. If you want equal, you must copy the full thing. Very lazy. I don't want to do that. So here's a technique for presentation. Don't put equal sign here. Leave it blank, and then you simplify one of the expressions you want. And then finally, integral sign, you don't even put the limits because it's just tagging along, right? Don't need to put. The ultimate goal is to realize it becomes a negative cosine 5x. Okay, this one is a very important presentation idea. Don't put the equal sign if you don't mean it. You put equal sign here, it's logically incorrect. Make sense? Don't put. If you put equal, you have to be precise. So integrate sign, you get negative cosine divided by 5. Then square bracket, this time you must remember to put the limits 0, 0.5 pi plus c. Okay. Oh no. Wait. Let me continue. Okay, good. So then we just have to sub in. So this is the boring part. So nothing very difficult, just have to substitute in. I'll use pi over 2 instead, okay? And
Okay.
so this is pi over 2 times sine of 5 pi over 2 over 5. Oh, no space already. Upper limit done. Minus away, lower limit. And do the same thing, but this is 0. 3 times 0 square over 2 plus 0 times sine of 5 times 0 over 5. Of course, it's just 0. Minus away 1/5 times of, this guy is negative cosine 5 times pi over 2 over 5. Minus away, negative cosine 5 times 0 over 5. Question, is cosine 0 equals to 0? Is cosine 0 equals to 0? Yes, no? You see 0 straight away, 0. Is that correct?
No.
Ah, 0. Substitute 0. Must be 0.
1.
No. It's 1. Ah, so this is a trick. Appear in A levels. A lot of students will just think, oh, sub x equals 0 must be 0. Don't need to think. But here they trick you with a cosine. So cosine 0 becomes a 1. You have to be careful when you evaluate. Simple but tricky. So this guy, let's simplify for some. Pi square over, let me use a different color. This guy is pi, that's my weight. This is pi square over 4. You times 3 over 2. So that's 3 pi square over 2 times 4 is 8. And this guy is sine 5 pi over 2. Let's think about it. 5 pi over 2 is really just how many pi's? 2 pi plus pi over 2, right? Pi over 2 is 2.5, which is two wholes and 1/2. So 2 pi plus half a pi. What happens when you plus 2 pi? You can essentially ignore it, right? 360 degrees. So this is just the same as sine pi over 2. Does it make sense? Sine pi over 2 is?
Sine pi over 2 is 1.
Yeah, correct. Okay, so it's 1. That means that this guy here, okay, I don't write so much details. I'll just strike it off and put a 1. Okay, then you end up with plus pi over 2 times 1. Yeah, you try to use black and red. Pi over 2 times 1 over 5. Okay, never mind. Very messy. I'm just gonna keep everything as black. Looks good. I think. I don't know. Next, continue minus bracket. This is 0. This one really 0. So we can just not write it. Minus 0, 0 plus 0 is just nothing. Erase. Minus away 1/5 times of this guy. Cosine 5 pi over 2 becomes, I'll write it at the side. Cosine 5 pi over 2 becomes cosine of 2 pi plus pi over 2, which is just cosine pi over 2. What's cosine pi over 2? Zero, right? Here. Oh, very messy. Okay, so cosine pi over 2 is over here. So it's a 0. All right, so that means that this is negative 0 over 5. Okay, never mind. Don't just put this 0. And then just simplify straight away. Don't need to write 0. Then minus here becomes a plus. Cosine 0 is a 1, so 1/5. Simplify. Finally, we get 3 pi squared over 8 plus pi over 10 minus 1 over 25. Okay? Is that okay? Okay, then I need to use the toilet. Maybe you think about this part 3 first. I'll come back in a while. Okay? Part 3, you think about it first. Try first. I'll be back. Hello.
Oh,
Yeah, so have you solved it?
um,
Yeah. Yep. Wait, I scroll down and give you more space.
it is wrong already.
Correct, it's correct.
Okay.
A plus B bracket square, then just multiply out. Right, so it's a bit faster instead of expanding out 4 terms. Just simplify straight away to 2AB.
Oh,
Right? And 2AB, 2 times 3, 6. Very good. Yep.
integrate cosine, you get sine.
Right. Like, just sign. Sign what? Ah.
Wait, divide by 5.
Yes. Differentiation times integration divide. Okay, then the rest, the left piece and the right piece just substitute. Is your working is perfect. Okay, good. Just have to substitute in. But then the middle one, wait, I noticed one slight
Is
mistake.
this integration by part?
No. Okay, wait, one mistake here over here. There should be a pi.
Oh.
Yeah.
Okay, now my
Yeah,
pencil
okay.
is not working.
Okay, I don't know why it's not. Okay, now this part here. How to integrate a power tool. So refer to the ultimate cheat sheet. Your pencil not working? Okay, I don't know. This power tool. Let's refer to the cheat sheet. Let's see. Okay, wait. I record down your answer first. 9x square bracket 0 to 0.55 plus integral 0 to pi over 2 plus square 5x dx 5x. Okay, and then you plus 6 times of sine 5x over 5. Close the bracket 0 to pi over 2. Okay, then let's look at the cheat sheet. If you read it again, you'll realize that actually under trigonometric, there's 3 parts. There are 3 types of trigo functions: basic, squares, and product. Basic, squares, and product. So for the basic types, it's these guys, the 6 functions you know. Sine, cosine, tangent, standard, need to memorize. Then for the ones with asterisk is provided in MF26. Oh. Then the other 3 is the special ones, the complementary. But here we're at the squares, so I'll just look at squares. For product, we already went through that time. It's using a product to some formula. I don't go through again. The other 2 special cases is secant times tangent, cosecant times cotangent. It's the reverse of differentiation. For squares, more importantly, we have sine square and cos square. You must memorize this, okay? You need to memorize
Okay.
this. You use the cosine 2x formula. So what's the cosine 2x formula or 2a? Let's see first. It's over here. So for cosine 2a, it's equal to what? 3 versions. Cos square a minus sine square a, 1 minus 2 sine square a, or 2 cos square a minus 1. Right? Then you gotta use number 2. Right? Sorry, we are dealing with cosine square. Sorry, you gotta use number 3. 2 cos square a minus 1. So let's do that. I think you know this, right? I think I've seen you do it before.
What?
Integral of a square function. I think you just forgot. You start with cosine 2a equals to 2 cos square a minus 1. Then you make cos square a the subject. So you plus 1 to the cosine 2a. But that's 2 cos square a, so you divide by a 2. Then? Yes. Minus 1 bring over become plus 1. Then there's still a 2 in front, so you divide over. Okay, good. So that means that you can substitute in the cos square 5x. With a trigo identity, which is cosine 2 times of that angle plus 1 divided by 2. What's 2 times of 5x? 10x.
And yeah.
Correct. The a turns into 2a. The 5x turns into 10x. Right? Then you can factor out the half, so you're left with 1/2 times integral of cosine 10x plus 1. Half times off, that's an invisible pair of brackets. Integrate cosine, I get sine 10x by divide by 10. Plus integral of 1 is x. And then you put square bracket 0 to pi over 2. Or x equals 0 to pi over 2. Okay. Substitute in and you get your answer. I think the substitution step we skip, you can do, right? You need me to go through?
Yeah.
No.
Yeah.
Okay, good. Move on. Okay, what was the last part? There's a part 3 to the question. Is it? Was this part 3? Oh, it was part 3 already. Let me label the part 3. Question 3 part 3. Okay, move on, move on. Okay, what time is it? It's already 11. Wow. I want to teach you Gaussian elimination. Gaussian elimination, what is that? Yeah, I'll talk about it later. Let's just continue solving first. Maybe better to go one step at a time. Okay. So go on to paste image. Okay, so question 5, let's see. So part 1 asks you to differentiate 2x e power something. I'm just gonna write it like this: d by dx of that thing. Then what rule do you use? Product rule, right? So let's keep it
Okay.
as 2x and e power something. So differentiate the 2x, I get a 2. Copy down. Plus. This time I keep the 2x instead. Then I differentiate the e. So I get back the same thing, but I times a -2. Product rule. Or clean up 2e power 1 minus 2x minus 4x e power 1 minus 2x. Positive 2 times -2 gives me the -4. X times e power something. I can't simplify, just leave it alone. Then you might say, oh, I see common factor e power 1 minus 2x. Then you try to factorize it. But I guarantee you that this will make your life worse. You see a factor 2, you factor out, it will also make your life worse when you factorize. Instead, this version is more useful.
Okay.
Why? Separate terms. Separate terms, you can integrate term by term. What do I mean? Look at part 2. Hence, find the exact value of this integral. 2x e power 1 minus 2x.
Integrate
Please
both
don't use
sides.
integration. Correct. Yes, you remember. This one is not using integration by parts. Even though you can.
Now,
Okay.
now my pencil is working.
Okay, good. Wait, hold on. Can I just correct you a bit?
Sure.
This part should be the derivative
Oh
of
yeah,
the
yeah,
common
yeah.
diff.
Cancel, cancel.
Then they can cancel away. Dx with dx. Oh. Okay, so yeah, I just left it this. Good,
And
good.
make this one the subject. So move this here.
Okay. Wait. Let me see first. Who is the subject? You look at the question, what they want. X times E. So who should be the subject? The one that resembles the question. X times E power 1 minus 2x.
Wait, then now I'm confused. Wait,
Subject means it's on its own on one side of the equation.
yeah, wait, now I'm confused. I thought I knew this. I thought I was like,
Yeah, you just selected the wrong subject.
yeah, it's not this. Man, I mean, it's not this.
And there's only one choice left.
But this is like the, this is this, but like.
Don't have integral, so it's different. Wrong. Then what's the
But
last
this
option?
is,
This is, look,
I mean, it's the same thing, but it's like instead of 2 is -4.
you can introduce a 2 on your own. Times 2 divided by 2.
Okay.
Times 2 then times half. Factor out the half. Right, times 2 times half means you times 1, so it's the same. So your objective now is to make the right guy integral the subject. Hey, wait, don't delete your working. So now we're gonna make the right guy the subject. Continue.
Well,
2x times what? E to the power, not just x to the
oh
power
yeah,
of
yeah,
minus
yeah.
I missed out a E. Yeah, 1 minus 2x to the power of E. Good. And from there, okay, one trick is 4 can rewrite as 2 times 2 also. So yeah. How to integrate? It can integrate already. 2 times E power.
How to integrate?
Write down the 2 first.
Mhm.
How to integrate E? Huh?
It's just E.
But you need
Then
to
need to divide by need to divide by -2.
yes, correct. Okay, finally. Divide by coefficient of x. Okay. Then just copy down. Good. And then the 2 can cancel away, right? 2 over -2.
So it's just negative E
Correct.
1 minus.
And then finally, you need just integral 2x e power 1 minus 2x. So the times 2 outside, you can, the times, where's my mouse? The times 2 outside here, you can
Divide.
just divide over. So half times the whole thing, or divide by 2. Good. Okay, then now you bring in the limits 0, 1. 0, 1. You can just write in 0, 1. Then square bracket 0, 1. Then just substitute it, right?
Okay, no need lah.
Yeah, don't need. I think you understand how to do that. Okay, that's the hands question. Good. Okay, try again. Okay, do it yourself. Okay, so hands fine, right? This is a hands question. It's a AMAX style question, but actually you could have done this directly using integration by parts. Let's try that instead. Oh, so let's try and find this the answer to this, but this time using integration by parts. So what you gotta do? Set up the table. Okay, can you remind me how to draw the table?
Yeah, okay. U
You here.
V prime U prime V.
Okay, good. What's the mnemonic? L.
Lie
Like it's like I lit. I lit. I then lit. But you sort the
Log-
order. Okay, whatever. Okay, so
logarithm inverse
inverse trigo.
algebraic or inverse trigo algebraic trigo exponential.
Good.
Yeah, okay, then how?
Then how? Who do you select? What do you select?
So
The top row.
this one is for U, now for V prime.
What's the logic? What's the
What's the
intuition?
logic?
Why left side is you?
Possible to
What do you want to do to you? You want to differentiate. What do you want to do to V prime? Huh? What do you want to do to V prime?
well integrate.
Integrate. Who is more difficult? Differentiate or integrate? Differentiation or integration? Which process is more?
Integrate.
Integration is more difficult. So which guy is more difficult to integrate among these guys?
Logarithm.
So you avoid, so that's why you want to avoid the L as V prime. I don't want L as my V prime. So that means it can only be U. Then the other end must be V prime. Does that logic make sense?
Okay.
Must understand the logic. Okay. So just memorize left side is U, right side is V prime. You forget, you mix up, you gone already. Must understand the logic. One of them has to be integrated. Very difficult to integrate the left side type of functions. So you go for the right side. Oh, so easy to integrate, right? Okay, actually both of them are easy. So good. Yes, algebraic on the left side, then the exponential on the right side. Now we just differentiate. So we get 2 here, integrate, we get back the same thing, divided by -2. Then just use the formula. What's the formula telling you? Don't put the limits first to save time. Equals to what?
Equals to what's the UV? Oh yeah. UV
You write yourself.
2x e -2 minus 2
Good. Then the 2's will cancel away. So that means that cleaning up what you get, 2 and 2 cancel away here as well. Oops. That's 2. Okay, I can't find the 2. Okay, then you end up with a negative x e power 1 minus 2x. Subtract away, 2 cancel away, you're left with integral of e power 1 minus 2x. Do you notice that we're doing the exact same working as before? I didn't record down the previous working. Do you realize it's exactly the same?
Which one?
Whatever we're doing now, it's exactly the same as what we did before when we try to integrate both sides of the equation and then what you wrote just now. Did you notice we're doing the same thing?
I mean, no, I didn't notice, but like, yeah, I see it's the same thing.
Yeah, that's how integration by parts is derived. You differentiate first, then you integrate. Differentiate using product rule, and then you integrate backwards. Okay, so AMAX is trying to teach you integration by parts implicitly by a part 1 and a part 2 of the question. Okay, what I'm teaching you now is actually A-level stuff. Integration by parts. Okay? After O-levels, A-levels. Okay. And yeah, then just simplify and substitute in the lower and upper limit 1 and 0. Okay, next. Go on. Let's try something more interesting. This one with the fractions one. So let's see question 6, part 1, 2, 3. Yeah, let's try and solve everything. Wait, let me see the time. It's 11:16. Maybe can I just teach you something else first? If not, I cannot assign homework.
Okay.
And I will go back to integration. We go through this Gaussian elimination. So we're gonna learn something new. To solve simultaneous equations, Gaussian elimination, also known as the row reduction method. So let's start with here's a bunch of things you must learn. I want to go through. So the first thing, let's look at an example. Here's how I plan the question. I start with x equal to 2 and y equal to -1 first. And then I just play around with the numbers so that I can get this equation, system of equations. So pretend you didn't know the solution. You got two equations and 2 unknowns. How do you solve? Simultaneous equations, right? You know how to solve this, yes?
Okay.
Okay. Okay, due to time constraint. Okay, can I ask you to leave and join back?
Okay.
Yeah. Let me